be showing that for A, B, C, D in R, if A squared plus B squared is equal to 1 and C squared plus D squared is equal to 1, then AC plus BD is less than or equal to 1. The first thing to note here is that this is an if-then statement. So we have to assume we assume this part and we prove this part and we prove this part. That is what. So we suppose that this is holding, then we prove that one. So we are going to use this supposition plus the properties of real numbers to get to the right side. So how do we do that? As you can actually see, we are seeing that we have A squared and B squared, and we have C squared and D squared. So we need to find a combination of this A squared and B squared, and the combination of C squared and D squared using the properties of real numbers. So suppose that, okay, let's say let A, B, C, and D be element of real numbers. We need a combination of A and B. So A minus B squared are greater than or equal to 0. This is a property of real numbers which is known. Why? Because we know that if we take any real number minus any real number, we get a real number, which is a real number minus a real number, we get a real number. Then if we square a real number, we just get a real number, which is greater than or equal to 0. So that is the property. And then the other part is we need a combination of C and D. So C minus D squared is greater than or equal to 0 as well. So these are the two which we need, which gives us a combination of A and B and C and D. So this one, after expansion, we get A squared minus 2AB plus B squared is greater than or equal to 0. That is what you get. And for this one, we get C squared minus 2CD plus D squared is greater than or equal to 0. These are the two which you get. So here, according to this one, we are actually told that A squared plus B squared is equal to 1. So let's work with the first one first. So we have A squared plus B squared is greater than or equal to 2AB. And the second one, we get C squared plus D squared is greater than or equal to 2CD. Then here, since A squared plus B squared is equal to 1 and C squared plus D squared is equal to 1, we have 1 is greater than, we get from here, this is just 1, so 1 is greater than or equal to 2AB, and this is just 1 as well. 1 is also greater than or equal to 2CD. Then as a result, you can actually see that we get we get 1 plus 1, if you add the 2, is greater than or equal to 2AB plus 2CD. So we get 2 is greater than or equal to 2AB plus CD. Okay, so just to write a proper proof, it's actually important to first put the supposition. So let's say this one. Okay, let me just rearrange this one so that it will make sense. Let A, B, C, D be in R. Suppose that A squared plus B squared is equal to 1, and C squared plus D squared is equal to 1. Then, by properties of real numbers, A minus B squared is greater than or equal to 0, and C minus D squared is greater than or equal to 0, which leads to this. A squared plus B squared is greater than or equal to AB, and C squared plus D squared is greater than or equal to 2CD. And as a result, since A squared, we are now retaining the supposition. If you check here, this is the supposition which we had initially. This one, we are retaining it, we are using it now. So the properties of real numbers section is this part where we were using the property of real number. The supposition thing is here. Then we add this one. We add this one and that one to get 1 plus 1 is greater than or equal to 2ab plus 2cd. Therefore, if we divide by 2, the result follows, and the proof is complete. So don't forget, whenever you're writing an if-then statement proof, you have to put your supposition so that like you use it in the midst of the proof to get to what you want. Okay, so thank you so much for watching. Please make sure you subscribe.